Well, shit. In the previous episode, I ran through the list of the many pieces of software that will make up an SS13 server, but I also teased I would go through the sheer lunacy that is the Paradise architecture. Let me make this very clear. You do not need this level of infrastructure to make an SS13 server work. Hell, CM, Skyrat, and many other big servers, excluding TG, make do with just a single machine. I just like to utilize everything to the fullest and properly confine things. Paradise, in total, spans 8 distinct geographic regions: California, Virginia, New York, London, France, Germany, Poland, and Australia. And we have a total of 19 servers all in. It's quite a mess, but each part plays a functional role. We're going to focus on the New York region because that's where pretty much all the business happens. If you remember all the way back to the first episode, I had this visual, or at least something very similar, describing how little CPU can be used by BYOND. Since then, we have had threaded maptic, which helps a ton, but throwing all 32 threads of a 14900K at BYOND is still silly. Not to mention, BYOND can still only use 4 gigs of our RAM, 192 gigs in this case. So what do we do with all these extra threads and RAM? Well, we carve it up. Side note, between the start of this series and now we've been through 4 different models of CPU, 3 of which same type. I'll explain later. Now, I'm not about to go all hello guys and girls on you, but I'll try and keep this brief. But essentially, if you have this many CPU cores free, you may as well offload them for other things that are required for a server. We have 9 VMs, which I will get into in this video, but the special part is that each of the virtual machines are hard locked to their assigned cores as seen on the diagram. This ensures that the resources of the logging server, for example, can't eat away at the resources marked for BYOND, and so on. Anyway, let's start with Latte. Side note, I named all the servers after coffee. It seemed funny at the time. Oh well. Also, quick disclaimer, yes I know this could be done with containers, please file your complaints in the nearest shredder, I do not care. Anyway, this machine serves as a dedicated router. It has 4 of the CPU cores and 8 gigs of RAM, as you can see on the diagram. Is this overkill? Absolutely. Do I care? Absolutely not. Anyway, there are several good reasons for a dedicated router machine, most notably not having to expose a machine fully to the internet at the mercy of an OS firewall, as well as providing a means for multiple VMs to access the internet with only one external IP. It also allows you to have a management VPN to avoid exposing SSH and remote desktop to the full internet, which is a nice peace of mind thing. Obviously with this, you can do a lot more than just have management for some VM networks. You can have VPN outbound rules for IP masking, as well as required messing about to handle tons of relays with IP decoding, which I'll get onto later. Having a dedicated router if you run more than one VM is pretty much a necessity, otherwise you have to handle accessing multiple servers on the same IP and messing with different SSH ports. It's also worth noting that the hypervisor itself also runs its network via this. It has no external IP and can only be managed via the management VPN. This helps a lot with security and just generally helps with keeping everything on the same subnet. Next up is the core server, Cappuccino. It has 4 cores and 16 gigs of RAM as you can see, and this handles not only the database, which is pretty crucial for the SS13 server itself as I explained in the previous video, but also the backends for other auxiliary services, such as the proxy manager, some internal ban evasion check stuff, a Discord bot, a Redis server for getting data in and out of the game easily, and some GitHub automation things like the PR label bot. A server like this is where you would put something like the PR mirror bot if you were running one of those, or any other automation that doesn't directly relate to the BYOND server, excluding the web server, which I'll get onto now. The web server, Americano, has 2 cores and 8 gigs of RAM as you can see here. As for why this needs its own server, there's a very good reason. The main 2 things an SS13 server will run as web apps are the forums and wiki. The forums tend to be relatively safe, Paradise is running Vision Community, but almost all wikis run on MediaWiki like I explained in the last video. MediaWiki is, put politely, a security nightmare. It's full of vulnerabilities bad enough to cause the leaking of Goon a while back, but fear-mongering aside, this is why the web server is on its own isolated machine, essentially a gulag for it. If anything were to happen, worst case scenario, only the wiki or forum files are breached, with the database being on another machine. and given the wiki just uses forum OAuth to sign in, nothing on the wiki has any passwords or sensitive data available to it. That being said, I have been very tempted to properly containerize the wiki just to completely isolate it from the rest of the machine. Anyway, the web server has a few functions aside from this, such as the PR callback script from GitHub, which is what does the PR announcements in-game, as well as serving files from the game server, such as the resources, runtime logs, and profiler info. For those curious, the game resources are served from the web server instead of BYOND, as that takes the load off of BYOND, which is really important to do for performance. The less BYOND is doing, the better. Speaking of which, let's go to the BYOND VM. The BYOND VM, Espresso, is quite possibly the most important VM here, because that's the whole point. All of the VMs run on Linux, or BSD in the case of the router, apart from the monitoring VM and the BYOND VM, both of which are Windows for a very good reason. BYOND on Linux has issues that affect some code bases and introduce a ton of microstutters due to constant file I/O on the ban file. File I/O in BYOND is a blocking process, hence microstutters despite the CPU usage being minimal. Because of this, we run on Windows. On this box, we run TGS, and that's it. And that's for a very good reason. You want your BYOND VM to be as lean as you can make it, otherwise other processes can eat into the BYOND resources, and we don't want that. To give you an idea of how lean this VM is, here is Task Manager from this server. And remember, this is Windows. The game itself is using about 1.3 gigs of RAM, TGS using about 250 meg, and the log forwarder is using about 230 meg. Windows itself is only using 2.3 gig, which will still make the Linux purists cry, but would put any other Windows machine to shame. Here's my PC, for example, and I don't even have that much open. Anyway, next up is the logging VM, Cortado. You'll notice this has a lot more RAM allocated than the rest, 24 gigs to be exact, and there's a very good reason for this. Logging is based on the ELK stack, which is Elasticsearch, Logstash, which I'm 99% sure we don't use, and Kibana. Elasticsearch loves to store data in RAM as a massive cache. That is why this VM has so much RAM. This machine right here is one of the absolute gems of this infrastructure, as it allows us to get tons of insights on our data. Not only can we see game logs outside of the game, but even do things such as map radio use to in-game areas, isolate logs to just one area, for example, wanting just attack logs from the bar during a bar fight, as well as getting tons of insights on development-related data, such as runtimes, and we can then aggregate what's causing the most runtimes, get data on garbage collection, such as what does and doesn't collect properly, what takes the longest to delete, and what type's the worst, and even see data on what all the subsystems are doing, graph time dilation against CPU, all sorts of useful performance metrics. This gives us pretty much a full looking glass on the data from the game. And the funny thing is, Elasticsearch can do so much more, and even has some really cool enterprise stuff like SIEM and system monitoring. But I'll be completely honest, I don't get how half of this works. The reason this is in its own VM is so I can delegate it to Dengus, who does absolutely wonderful work with the stack. Everything I've shown you has been work he has done, and it's just brilliant. Now we are on to Ristretto, which has very few resources allocated to it, only 2 cores and 8 gigs of RAM. The whole point of this server is for an internal GitLab, which holds server config files, various policy documents, and a share to hold various assets for admins to use while ruining grounds with events. The reason these are on GitLab and not just a folder for the SAM files, or just using TGS static files for the game config, it allows us to vote on configuration changes, as well as have a full paper trail for any changes being done. It's quite a nice system. The reason the specs for this VM are so low is because GitLab likes to eat all of the resources it has available to it, probably because it's built of 10 ancillary services just to run the bloody thing. This is why it's confined to its own VM with barely any resources available to it, because then it physically cannot escape the confines given to it. This is Arabica. It has a small amount of resources, 2 cores and 8 gigs of RAM, and this is purely for running PRTG. PRTG is network monitoring software, and it's responsible for things such as rendering this abomination, as well as giving stats on machine vitals, network traffic, and more. However, PRTG only runs under Windows, hence this getting its own VM because it's not going on the BYOND VM for reasons I stated before. You may be asking, why the hell are you using PRTG when you already have Elastic for all the monitoring? It is a valid question, however, PRTG is just nicer to use and to get a grip with all the stats, not to mention it can probe via SNMP instead of having an agent, and it can automatically discover what's available on each machine. Oh, and it has the network maps that allow me to plot things easily, and the fact it's a lot easier for me to use than Elastic, even if it may be missing some features. All this VM does is provide monitoring stats of the entire infrastructure. That's it. The next VM, Robusta, is similar in how it's a very specialized affair. It has 2 cores and 8 gigs of RAM as well, and this VM is entirely delegated to Korn/Eden. This runs the stats website, and this is in its own VM, so I can just delegate the entire thing and not be nagged for when updates need sorting out. Again, this could be a container, but neither of us can be asked to sort Docker deployments out. Finally, we have Affogato, the on-site backup VM, and it also has 2 CPUs and 8 gigs of RAM. However, you'll notice the CPUs aren't mapped out. That's because this uses so little CPU there's no point mapping it out, and definitely not because this VM was an afterthought realization. For a bit of context, we do backups with Proxmox Backup Server, which allows me to save all these VMs as images, which I can then either restore as a full VM, or just grab a single file out of said VM. We used to do these straight to our offsite backup server, which I'll explain in a bit, but due to how the backups work and the need to send data transatlantic, it wasn't viable. Proxmox, the hypervisor we're using, does backups by temporarily freezing a chunk of the virtual hard disk that's being backed up, sending it off to the backup server, then moving to the next chunk once the chunk it was doing has been done. As you can imagine, this can cause issues if it takes a while to transfer that chunk, especially since SS13 is quite disk heavy, since not only do you have all the logging, but then the fact you need to do a disk operation every time you want to do an icon blend in-game, which is still silly, but oh well. Due to this, we have to snapshot our backups locally, and then have a process to send these to our offsite backup, which I'll explain in a minute. That's all the VMs explained. Yes, there's quite a few, but as you can see, this is a good way of effectively carving up the CPU resources to make the best use of them, and with the way I have it set up, the cores allocated to each VM are exclusive to that VM and can't be used by other VMs running on the system, which is great for preventing resource overlap. You can also see there are 2 cores left for the hypervisor itself, so that it can still process its own updates. Now we have the rest of the servers around the planet, specifically the relay servers, which are split into 2 groups, as well as the offsite backup server. Side note, while editing this, I've just realized I've had this map wrong for 9 fucking months now. The VPN traffic goes via Relay Group Alpha, not the offsite backup. This should be here. Anyway, Relay Group Alpha has 1 server, which technically doesn't make it a group, but who cares? The server in question, Cthulhu, is a small VM running at another cloud provider, and it has a beefy firewall, which helps us withstand DDoS attacks. The worst we have had is 271 gigabits a second, and this has tanked it without anyone even noticing, and I feel the need to put that into context real quick. The maximum speed of the network card on your PC, assuming you aren't using 10 gig or similar, is 1 gigabit, and that's the maximum you can get out of the port itself. So you'd already need 272 of your computer's network cards fully maxed out. Then we take internet speed into this. For me, that's about 40 megabits a second upload, or 0.04 gigabits a second. You would need 6,800 of my internet connections to achieve that level of traffic. It is utterly insane how big these attacks are these days, but even more insane to me is that the firewall for this VM completely tanked it with no impact to the game. Anyway, for Relay Group Beta, I need to bring the world map back. Let's say you're in France. First of all, ew. But second, when you connect to Paradise, your internet provider has to figure out how to get from France to New York, which has to go over a lot of hops, and it might not give you the best route. The alternative is connecting to the relay server in a city in France, which is a much shorter path for your internet provider to have to figure out. Not only does this make it easier for your router to get the packets there, but these relay nodes send data to each other over a private backbone instead of the raw internet. As you can see in the traceroute on the screen, all the hops in the chain apart from the start and end are on the private IP space. They start with either 10 or 192.168, both of which are private IPs. This means that the routing between these two servers is privately managed on said backbone, allowing for said route between these servers to be very efficient with minimal added latency. My ping using the UK relay compared to a direct connection is about 10 milliseconds lower, which is a nice bonus, but a lot of people have reported more stable connections using these relays, with not only lower ping in general, but reduced spikes in times of high usage and the like. Finally, we move to the offsite backup server, which is in Germany. There were two reasons for this. The first, it's cheap. And the second is that it's geographically very far away. If New York got nuked for whatever reason, FYI, I deployed this back in 2021, way before the world got interesting, we'll say. But say New York did crumble, there's a very good chance that Germany will be fine for long enough for me to pull the data off the offsite backup and remake the server elsewhere, or put it on tapes that I put in a farmhouse in the middle of nowhere. The backup server also runs Proxmox backup server to mirror backups from the New York on-site backup, as well as running our snapshot on a schedule to get raw copies of the game logs, web server files, and database snapshots in case we need to fully rebuild, in the unlikely event that the VMs got backdoored or similar. The real special sauce with the backup infrastructure is that the backup server itself is what initiates the backups via a pulling method, instead of the core server pushing files to the backup server. This adds an extra level of safety, as in the event that the main server got backdoored, it has no access to the backups directly, so it cannot delete the backup data. And in the even more unlikely event I didn't notice that something was wrong within a day, we keep 7 days of snapshots. So even if everything got wiped out on day 1, we still have an entire week's worth of data to go back on to recover. So yeah, that's it. That's what makes it Paradise. Yeah, there's a lot of stuff, and yeah, there's a lot of information, but again, I must stress, you do not need all of this to run an SS13 server, especially not the relay groups. This is more of an example of just how far you can take things. And remember, I don't even have formal sysadmin qualifications. This project is extreme, it's a passion project, and it's pushing hardware to its absolute limits. Although to be fair, I should probably stop doing that. About a year ago, we managed to kill a 13900K with BYOND. I wish I was joking, but let me know if you want a Kevin Fang style recreation of how that went down. Anyway, that's all for now. I would say this is an end to the series, however I did think of a part 4, which is why running SS13 on a cloud provider like Azure would be absolutely horrendous. So expect that in like, I don't know, a year maybe. I'm sorry the series has already gone on for over a year, but that's just how life is. Anyway, see ya.